Hello and good morning or good time, whatever time it is for you. In this video, guys, we're going to be talking about chemical changes and how to balance chemical equations. So I'm just going to run through these notes with you guys. I'm going to break it up into two videos. This one is going to go over more of the concepts and the vocab, what to kind of see on chemical equations, the terms. And then the second video is just going to go over some examples of how to be balancing chemical equations. So, to begin, we are getting into the area now where we're going to be writing out chemical equations. And within chemical equations, we always have two things. We have reactants and we have products. So if we think about like making a cake, what are the ingredients that go into making the cake? What are the reactants of it? You have milk, egg, flour. You can combine them all up. You add heat, put it in an oven, it comes out, and the product would be cake. Chemical equations are very similar. We are taking ingredients, quote unquote, or reactants, in this case, hydrogen gas and oxygen gas, and we add them together and we put them in a system. Maybe we apply heat as well, and we get water, H2O. Okay, so it's the same idea. We're using reactants and ingredients, elements and molecules, combining them or moving them around to create products that have different properties than what they started with. Right. So like I said, the substances that react are called reactants. Those are the beginning elements or substances. And the thing that gets produced are the products. So, and this kind of started with a French chemist named Antoine Lavoisier, and he figured out that the total mass of the products always equals the total mass of the reactants, right? And so what he did is he had a candle, and he put like a container around it, and he started burning the candle, and he noticed that as the candle was burning, that the mass was not changing, right? So he used a scale back in the time, and so before burning and after burning, it still weighed the same. So meaning that the oxygen gas that was being used and the carbon dioxide gas that was being produced from a flame reaction or combustion reaction doesn't actually get rid of anything. And this led to this idea of the law of conservation of mass, where matter cannot be neither created nor destroyed, right? We can't just pop into existence a hydrogen atom. Every single atom that exists has existed since the Big Bang Theory, or since the Big Bang. And nothing has been added or subtracted since that singular moment. It's kind of crazy if we really try to comprehend and think about everything that is made up of matter, which is everything we could touch, and realize that all of those things have come from different stars and different planetary objects or asteroids, meteors over billions of years. Right? But that's the reality. Nothing gets created nor destroyed, nothing gets added or subtracted in this system or in this universe. Okay, and that'll lead us into this idea, this law of conservation of mass or conservation of matter will lead us into balancing chemical equations. Before we get to that part, we still want to talk about writing chemical equations. So we have some symbols here on the left-hand side. And so whenever we see this arrow, which will be in every one, that's just going to tell you or separate your reactants from your products. Your plus sign is adding two things together. And then we have some parentheses here that's going to tell you the state of matter that that substance is in. S for solid, L for liquid, G for gas. The AQ, that it means aqueous, that means that that substance is dissolved in water. Okay, so we wouldn't see it like isolated or on its own. It is in a solution. And then the arrows with some terms on it, that's if you apply heat, light, or electricity. All right, so within chemical equations, Lavoisier, with his idea that, or his experiments that led him to determine that the mass doesn't change before and after an experiment, leads us to this idea that chemical equations need to be balanced, meaning the elements on the reactant side have to equal the elements on the product side. Okay. So if we look at this example again, H2 plus O2 equals H2O. If we do a quick accounting, we have 2 hydrogens on the left, 2 oxygens on the left as well, and then here there's an issue because we have 2 hydrogens, that's good, but only 1 oxygen, right? So that's a problem where the number of oxygen atoms do not match up. Okay. So fixing this equation, and we do need to fix it, this requires a process called balancing. And what we need to do is add coefficients. Okay. Coefficients are these large numbers, not large numbers, but just numbers you see in front of elements. Okay. So the coefficients we place in front of different substances to achieve a balanced chemical equation. And what we're going to see as we do this is how we can determine the amount of element in a molecule and how many are on the reactant side as well as how many are on the product side. And before we get to the actual problems, just a little bit more vocab. So the little numbers we see here underneath, those are our subscripts, right? Those when you are balancing a chemical equation, you will never change those subscripts. Those are just staying still. They're not going to change. The only things we can change when we are balancing chemical equations are the coefficients, which are the numbers in the front. Okay, so looking at this, we're going to balance this chemical equation together, and then the ones below we will save for the next video. So you can kind of think of it as like a game. This is if you've ever had a job where you needed to keep track of money or keep track of a certain type of item. It's the same idea, right? Where the key to the game is to have an equal number of atoms for each element on the reactant side and the products. So we're going to follow this procedure list down here. And the first thing I'm going to do is just draw a line underneath the arrow. That's going to help me keep track of the things on the left and the things on the right. And next, we're going to list the type of atoms below the equation. So we'll do carbon, hydrogen, and oxygen. And we're going to count how many atoms there are on the reactant side first. So carbon, we have 1, hydrogen 4, oxygen 2. And then we do the same thing on the product side. And you want to make sure your elements are in the same order. Right? Carbon goes with carbon, hydrogen goes with hydrogen, oxygen with oxygen. When this gets more detailed, that is going to be especially helpful just in terms of not getting lost or not getting confused. Just a good way to stay organized. And so if we look at this, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens. Is this balanced? No. All right, so we need to fix it. So there's a few areas we can try to start. And so this is really also kind of a trial and error thing where you have to kind of move around the equation and change and rechange the coefficients until you get to the correct numbers. So the first thing I see is that hydrogen is 4 on the left and 2 on the right. So I'm going to go ahead and add a coefficient here. I'm going to add a 2 here. Okay, and what that 2 is going to do is, think about math, when we put a 2 in before a parentheses, what happens? That 2 gets distributed out amongst any numbers in the parentheses. Because if we think about it conceptually, we have a hydrogen atom. This coefficient is 2. It's telling me that there are 2 hydrogen atoms. All right? So now we have 2 oxygens from this water side. Now we have 4 hydrogens. So if we recount the products, we still have 1 carbon. We now have 4 hydrogens because we are timesing the coefficient times the subscript. Okay, so 2 times 2. And then 2 times oxygen, that's 1. Or, excuse me, 2 times 1 is 2. And then we add it with our O2 over here, and now we have 4 oxygens. So our hydrogens are good. That's good. We don't want to treat it as a checklist because we're going to kind of continue to move things around. But now we need to move the oxygens on the reactant side, right? Or we need to add a number. So we have O2 here, and I'm going to put a 2 in front of it. And that's going to distribute out again. So that 2 becomes a 4. And then we double check. We are good with carbon, good with hydrogen, good with oxygen. Notice not all compounds will have a coefficient. In this example where we have blanks, you can either just write in a 1 or you can just leave it blank. Either is fine. But this equation is now balanced. The next video will kind of go over more examples, and if you have any questions, let me know.